Mamma mia, why is there so much outdated technology? This is so bad, man. We can't have this lying around. They're essentially pieces of scrap that's clogging our park.
Yeah, I mean, all this trash is gonna make the park actually kind of dangerous. Because
Dude.
when you walk around, you're gonna like trip up on it and whatever.
I mean, you're right, because we're in the middle of a construction phase. We have all this trash just lying here. What shall we do?
I mean, we're probably gonna need to get something to clean it up, right? But then it's kind of annoying to hire like an actual person to clean it.
I have an idea.
Let me put my thing.
Shoot.
We can get a robot to clean it up.
Ooh, a
How
robot.
about that?
A robot, dude,
Yep.
that's
What would
amazing.
you name the robot?
Cleaning
Wall-E.
robot. We're gonna
I
name
think
it.
cleaning robot is better.
Yeah, that works too.
We're gonna do this because we have so much trash on the floor, metallic trash, because we are going through a industrial phase on our Mars expedition. We're gonna attach an arm connected to a motor, which will help raise and lower a magnet. So all this filthy garbage from the 20th century will all get picked up by this arm. And we'll also have a slave robot, which will essentially carry it to the trash bin. You see, this is some amazing technology that you can only do with the power of AI.
So, you know what we're gonna do for a robot, right? Like how we're gonna design it and stuff.
Wowzy daisy, I don't know.
All right, so we're gonna use a metal arm, like a metal detector thing, like you said before.
Yeah, but why?
Because if we use an arm, most of our stuff is scraps, is
Yeah.
metal scraps, not.
Okay, so you need a magnet for metal scraps if that's the thing we're moving to clean up,
Yeah.
right? And it would be better because we could use the incredible gravity on the planet Mars to pick up things instead of having to use additional power that we needed to move a mechanical arm.
Exactly.
Exactly.
And also, we're gonna have an ultrasonic sensor so we can, you know, detect the range of, like the distance from the sound of the object.
Why not a LiDAR though?
I don't know, you tell me.
Oh yeah, because like a LiDAR, it has more limited range, while an ultrasonic could shoot out sound beams and get accurate tracking of the object, you know?
Yeah.
And of course, since different scraps are different colors, we need to decide which scraps are our final design, which scraps are the ones we need to throw out, and what scraps are the ones that we need to disregard. So a color sensor will be able to detect if this is labeled as a scrap or if it's labeled as an essential design choice.
The only problem is it can't pick up plastic that's brought from the earth because we will use metal for everything in our park.
Ah
Or at least
man.
most things, yeah. That's the only problem.
But the thing is that a large portion of our trash has to do with these scraps in the first place. And we are gonna go under heavy workloads for designing our park. So it will make up a majority of our cleaning work.
Okay, so what this robot system does is that we're gonna have two robots. You see this robot with a magnet is picking up right now, and then it moves forward, and then it puts it in like the basket of the other robot, which is basically just like the trash, right? And then it moves it away to wherever it needs to move it, right? But for the code of this robot, the first robot, which is number one, it moves forward at 20% speed on both of the motors for 1.5 wheel rotations, and then it'll pause for 1 second. And then after that, the motor E will turn on at like 50% power, so then it'll activate like the magnet, so then it works. And then after that, wait 1 second again, make sure that everything works well and evenly. So then motor D will rotate after that at 45 degrees at 6% power, which is just like slightly adjust. And then the robot will move forward again for half of a rotation, just so it makes sure that it can get into the basket. And it'll pause just to let him finish. Right. And then it'll stop motor E. It's just another short pause, and then it'll stop it. And then it'll wait half a second to stabilize before resetting the position. Right. And it'll go to sleep. And then motor C will go back to the position that it was originally at 6% power. And then same with the motor D, right? And then the robot 2, so it slightly moves forward closer to the first robot. So then it stops there for 10 seconds while it waits for the first robot to like pick up the object and put it in. And then after that, it'll rotate to the left by like 1.8 rotations, so that it can make sure that the scrap is moved into the pile, where the trash pile, wherever it wants to go. And then it'll push it away while rotating both wheels by 1.5 rotations.
Mamma mia, guys. I actually transformed into Mario. I've been chanting this every day for 260 days. I finally transformed into Mario.
Expelliarmus.
Wow, even you are Gandalf the Great.
Yeah.
Now let me tell you, I really dislike this because I faced a very challenging challenge. The challenge was that when putting the robots into the arena, they would be angled in a way that they would be diagonal instead of vertical, and I really found it frustrating because I had to put the robots facing each other or facing behind each other for it to work. Right? So using my very smart technical skills, I found out that you could rearrange the way the robots are set up by putting them vertically by doing the first player, so player 0, and on the bottom player 3, that would change them from being diagonal to vertical. Then I also found another challenge where my robot, when I coded it, it was supposed to pick up the block and it was supposed to turn behind it. But I knew that because the arena, the way it was set up, it made it very challenging for the robots to get behind each other, right? So my solution was the Mac would pick up the piece of scrap and it won't turn. Instead, it will just drive forward onto the other robot. I'll put it on the platform where it'll get pushed over into the heaping pile of trash. So you see that? It's very unique, very awesome. And with that problem-solving skills, we're able to achieve anything. Yahoo!
Why that low-key smart?
Yeah, it's so smart, man. Totally. I'm gonna eat some mushrooms now.
Why are you playing Snake?
Oh yeah, I'm playing Snake because this is a leading frontier in technology, man. I love Snake, dude.
On your calculator?
Yeah.
We're out here struggling with this other robot that we gotta do later, and you're out here playing Snake.
Yeah, because I'm a great CEO. Oh, I lost. Ah, man.
Yeah, you know how much we've been struggling and like learning all of this new stuff to get this robot working?
I don't know. What'd you guys learn?
I mean, I learned about the program. I didn't even know this program existed, you know, because I'm just the video manager. But I learned about the program and how to execute things into the program, how you import the robots, how you make the robots do things, how you code it.
Like the electromagnet.
Yeah, like the port and stuff like that. So
You could get the electromagnet to turn on.
yeah.
Great. Now, Willie, since you're the physics wizard over here, what can you explain about the physics in VS Code?
Alright, so I learned that like, since there's so many objects in the playground in GearSpot, that you need to have like forces on everything, so then everything doesn't just like slide around, so then everything works well together
Because
in the
people
systems of robots.
VS Code thought the friction didn't exist? Yeah. That's
Yeah,
kind of crazy.
yeah, no, because you need friction or else everything
Need
just slide
friction,
around.
man.
What about you, Yar?
So I learned how to import the like cassettes and how to design the robot so we don't have 3 wheels in a robot, so it can actually work good. And yeah, that's pretty much it because I'm just the quality assurance manager. I don't really care about the robots.
Oh.
I don't care.
Oh.
I need to assure the robots are doing fine. That's why I learned how to design them correctly so they don't run into people, you know.
Yeah.
Of course.
I found an interesting detail. So one thing I learned is that with our specially dedicated American robot software, they don't actually use a coordinate system, which I thought was pretty frustrating. But I figured out a direct measurement. So if you put in 360 degrees for like a tank spin at like 100% power, that will actually equal to 1,920 degrees total distance if 360 is equal to 1 rotation. Now this is so useful because now I don't have to struggle anymore to get exact position and measurements in the program. It's going to be useful because with this advanced American math, you can now effectively put the robot anywhere you want without guessing. Awesome.